Now, a coin is tossed. Just write down this. A coin is tossed 600 times. Heads showing up will be 342 times. Tail showing up will be 258 times. If a coin is tossed, what is the probability of getting a head? I will write something like this. Probability of getting a head, getting an event head. What is it?
$342/600.
342/600. How much is that? Can I simplify this with 6? Keeping 100 as it is. 6, 342 will go by 6. 57/100. What is 57/100?
0.57.
0.757. 100 is a, whenever we have tens, it's a magic number. I will not disturb that. It helps us in division or multiplication. Okay. Now, we know theory of probability. Can I use this to find out probability of getting a tail?
Yes, ma'am.
Even I can do 258/600. Yes, this is, we have learned. Using this concept, what is probability of a tail now? Can I write it is 1 minus probability of head? Because anyway, if I add both the probabilities, I should get 1. If I subtract probability of head from 1, will I not get the answer of probability of a tail? Which
Yes,
is
ma'am.
258/600. Yes. So how much is this?
Yes, ma'am.
0.43.
0.4. So I'm telling you to note here that probability of events for any experiment is always 1. Clear?
Yes, ma'am.
Shall we go to next event, next experiment?
Yes, ma'am.
Deepta, Jia, Shreya, noted down.
Done.
Yes. Now I'm giving you another experiment where a die is thrown 500 times. So number of trials is 500. And outcomes are noted below. So this is a problem given to you. When a die is thrown, what are the outcomes? We have discussed that, right? What are the outcomes when a die is thrown?
1,
Correct.
1 to 6.
1, 2, 3, 4, 5, 6. The frequency in which 1 has occurred is 95. Number of times 2 has occurred is 80. Similarly for 3, 68, 70, and 170. So the total number of trials it is done is 500 times. So this is 1 is showing up 95 times, 2 is showing up 80 times, 3 84 times, 4 68 times, 5 70 times, 6 103. If you add all these frequencies, yes, it will be equal to 500 times. Is this clear? Is the experiment clear?
Yes, ma'am.
The
Yes,
experiments are empirical probability. You have number of trials being done. So now question is, if die is thrown at random, simply it is thrown, you have to find probability of getting how many events this experiment has.
500.
500, that's number of trials. How many
No, no,
events does it have?
6 events.
6 events. I will get one among these 6 events. So what is the probability of getting 1? What is the probability of getting 3, 4, 5, and 6? Is the question clear to all?
Yes, ma'am.
So in this experiment, we have 6 events. I might get 1, 2, 3, 4, 5. But this is an empirical probability. So what is probability of getting 1? Number of times I get 1. What is number of times I get 1? How many times I have got 1?
94 times.
95 times. Yes. How many times I have got 1? Out of 500 times I'm throwing a die, I get 95 times 1. So what is it? 95 by? By?
500.
500. Again, is it divisible by 95 and 5? Is it divisible? I'll not count zeros here. Zeros are the friends. What is 95 by 5? It's not coming. Yeah. 5 ones are? 5 nines are? So how much is it?
0.19%.
19. Similarly, I want you to find probability of getting 2, probability of getting 3, probability of getting 4, probability of getting 5, probability of getting 6. Do this now. Are you all understanding this experiment, trials?
Yes, ma'am.
Are you all able to do? Gia? Able to do? No doubts?
No doubts, ma'am.
Ma'am, I'm getting a problem. The probability of third one.
Which one?
Probability of 3.
3 is how much? 84
84.
divided by
500.
500. How much is that? 84
Ma'am, I did it
by 5.
by 4.
Huh? 84 is not divisible by 5. So what will we get?
Ma'am, I did it by 4.
Why 4? We have 500 in the denominator, right?
Yes, ma'am, but it's not divisible by 5.
You have to divide by 5 only. You will have a terminating number. If you divide by 5, how much?
Yes.
5 ones are 5. If you divide, 5 ones are 5. 5 6 are 30. 5 eights are 40. Divided by 100, how much?
Ma'am, 0.168.
0.168. When you have in the denominator either 2 or 5, it will be a terminating decimal. So it will terminate 16.8. 84 will be divisible after some decimal places. Is this clear?
Yes, ma'am.
What about probability of 2? What are you getting for probability of 2? 80 by?
0.16. ma'am.
Yeah. So it is 80 by 50. So 80 by 50, I will take it as 8 by 5, I will divide. I'll get 1.5 ones are 5. 1.6 divided by 10. How much is that? 0.16.
0.16.
Yeah. What about probability of 4?
0.136.
Even now you can just divide this. So how much you're getting?
0.136.
0.136.
Yes, ma'am.
Probability of 5, getting 5. 70 500.
0.14.
0.1,
4.
only 14, 0.14. Probability
Yes,
of
ma'am.
6.
0.206.
How much?
0.206. 206.
Is everyone getting the same decimal values here?
Yes, ma'am.
Yes, ma'am.
Yes. Yeah. Here in this case, we can't use that, only for the last one we can use the sum because we have 6 events here. Now I want everyone, I want you to add all the events. Probability of 1 plus probability of 2 plus probability of 3. Just observe what you're getting. So I want you to add all the 6 events. How much are you getting? Observe when you add all the 6 events here. This experiment will have only these 6 events. So how much will you get?
1.
It's always 1.
1.
Yes. Here we can't find out if I know probability of 1 event. I can't find out the remaining events because we have many events here. Unlike head or tail, it was only 2 events. I could easily do